Hello everyone, this is Sakshi and I welcome you all to my tech platform Way to Learn. So today again we are going to solve problems from mathematical physics and today's topic is again from differential equations. My last video had the same topic differential equations which was part 1 and we had solved some of the problems like two problems from differential equations of first order. And today's session we are going to see differential equations of order 2. So let us see the second order differential equations. There are two cases over here. First one is the homogeneous differential equation. So when do we say that a particular equation is a homogeneous differential equation? You will have to see what is the RHS of your given equation. So here the RHS is 0 and hence you can say that your differential equation is a homogeneous differential equation. And here P and Q are constant coefficients. So now how do we solve this kind of differential equation? So we are going to write this particular equation in the form d square plus pd plus q is equal to 0 where d is equal to d by dx. And then we are going to write the auxiliary equation. So instead of d square, I am assuming that d to be m. So my auxiliary equation here is m square plus pm plus q is equal to 0. So since this m square plus pm plus q is a quadratic equation, we will have two roots. So based on these two roots, we'll have different solutions possible. So we are going to see like based on the roots m1 and m2 on solving our differential equation, how can we write the solution? So if the two roots that I get from the quadratic equation m1 and m2 are real and unequal. So real means it should not have any imaginary number. It can be an integer, it can be a decimal, anything, but it should not have a imaginary number. So it should not contain I in its term. Okay. So if m1 and m2 are real and unequal, then m1 will not be equal to m2. So the solution can be written as y is equal to a e power m1x plus d e power m2x. Second solution is if m1 and m2 are real and equal. If we have the same roots, then what to do? Then y is given as a plus bx into e power mx. So this is our second solution when m1 and m2 are real and equal. So let us see the solution 3 when m1 and m2 are complex numbers. So when m1 and m2 are complex numbers, that is alpha plus I beta, two different complex numbers, then our solution will be same as the first, a e power m1x plus b e power m2x. The solution 4 is when m1 and m2 are complex conjugate of each other. That is, if it is a complex number, m1 is alpha plus I beta, and m2 will also have the same number, but it will be a conjugate of m1, which is alpha minus I beta. Then the solution is written as this, which is y is equal to e power alpha x, a cos beta x plus b sin beta x. Alpha here is the real number and beta is the number which comes along with the imaginary term I. So we do not need to write I, we just have to write the number present. So this is our fourth solution. So let us see an example how to solve a homogeneous differential equation. So here is a differential equation, and if x is equal to 0, t is equal to 0, and x is equal to 1 and t is equal to 1, and we have to find the value of x at t is equal to 2. So first we have to solve this. We are going to write this differential equation as d square minus 3d plus 2 is equal to 0. Now I am going to write my auxiliary equation, which is m square minus 3m plus 2 equal to 0. And after solving, I get the roots to be m is equal to 2 and m is equal to 1. They both are real and unequal. So the solution will be x is equal to a e power 2t plus b e power t, which is the type 1. And now, according to boundary conditions, t is equal to 0 and x is equal to 0. So on substituting that, I get a plus b equal to 0 or a is equal to minus b. And the second condition was at t is equal to 1, x is equal to 1. So on substituting that, I get my b, and similarly I can write my a term. So this is my b and a term. Okay, so now I know my a and b, the constants, so I can substitute that in my solution. So after substituting, I get my solution x to be e power 2t minus e power t by e square minus e. Now the question says that at t is equal to 2, what is the value of x? So at t is equal to 2, we have to substitute wherever the t is, we have to substitute 2 in that place. And on doing that, I get e power 4 minus e square by e square minus e, where e power 4 minus e square can be written as a square. This is of the form a square minus b square, which can be written as a plus b into a minus b. So on simplifying that and cancelling the numerator and denominator terms, I get x to be e square plus e at t is equal to 2. So let us see the case 2, which is the non-homogeneous differential equation. So in a non-homogeneous differential equation, our right hand side will not be equal to 0. So you have to remember it will be some function of x. So RHS will not be equal to 0. It will be some function of x. Okay, so like a function of x, or if it's respect to t, then it will be function of t, whatever it is differentiated with respect to. Okay, so again, this above equation, particular equation is written as d square plus pd plus q into y is equal to r of x, and I can write this as f of t, where f of t is written as d square plus pd plus q. Note this down because this is going to help you in how to solve a non-homogeneous differential equation. So now, the solution of this non-homogeneous differential equations has two parts. One is CF and PI. CF is called as the complementary function and PI is called as the particular integral. So CF is nothing but it contains the same solution as done in our homogeneous differential equation. So we have to follow the same steps because CF represents the left hand side term. So we have left hand side which is in the form of a quadratic equation. We write the auxiliary equation and then find the roots and check whether like if the roots are real or unequal, like what type of solution do we have to use. That is your CF. And PF depends on our right hand side. So sorry, PI depends on our right hand side, which is the function of it can be function of anything, right? So now if I say my r of x is a function of exponent, that is e power ax or e power minus ax or anything. So then particular integral, then pi can be written as 1 by f of t. F of t here is d square, that particular term which is written in terms of d. So particular equation which is written in terms of d square plus pd plus q. So that is your f of d into e power x. Now what do you have to do? After writing this, you are going to substitute in the place of d as a. So wherever d is there, you are going to substitute it by a. So because e power ax, that is e has the term a, so you are going to substitute that a in your d terms. So after doing that, so that is your first step to find the particular integral. So if in case your f of a numerator goes to 0 after substituting the a value in your d terms and you get f of a to be 0, then your pi will go to infinity, right? So we do not need such kind of answer. So we are going to do another thing which is written as then if f of a is equal to 0, then my particular integral will become x into 1 by f prime of a. So you are going to differentiate that d term. That d function is going to be differentiated once. So it is differentiated once and you write this x term before, and after that again you are going to substitute a in all the d terms in your equation. So again, if in case, this will be the maximum time you do. But if in case, in some of the question, if you get f prime to be 0 again, then it is simple, multiply again by x. So it will give you x squared and then differentiate twice your d term, d function, and again substitute your a. So this is the simple process to find pi if your r of x is a function of exponent. Now if r of x is a polynomial of x, then pi is given as similarly 1 by f of t into x bar n. Okay, so here we don't have to substitute this a and all. We are just directly going to expand the series, expand our f of d in series, like binomial expansion or anything which is possible with that particular term. So this is a simple one. So after expanding, we get, if you have 1 minus d the whole inverse, then you're going to expand like 1 plus d square and so on. So after doing that, you're going to differentiate. That is one. You're going to multiply those terms with respect to your polynomial, given polynomial. So on doing that, you get 1 into x power n, which is x power n, then plus d into x power n. D represents d by dx. So you're going to differentiate at that time. So when you solve a problem, you're going to understand what to do with this kind of particular integral problem. So let us see the third type, where r of x can be cos ax or sin ax. Remember, cos ax or sin ax alone. So if it is like that, then again you are going to use your f of d square term. Okay, and then multiplied by sin ax. Okay, and then you are going to use f of minus a square. Wherever you have d square, there is d term, you are going to replace it by a square and have a minus sign. So this minus sign is an important thing. You have to remember that there is a minus sign over there. And then f of minus a square will be equal to, if f of minus a square goes to 0, then you are going to differentiate again as we did in the first case. So the last case here is if r of x is the exponent term into a polynomial, then your particular integral will be 1 by f of t e power ax phi of x. Here what you have to do is, you will have this d term as it is, and the next step that you're going to take is you're going to replace all the d by d plus a present in your exponential term, and you're going to bring this e power ax in the front, because when you expand this in series, this f of d plus a term in series, then you'll have to differentiate with respect to phi of x and all. So in this type of particular integral, you're going to bring this e power ax in the front after substitution. So I hope you get these steps. Write down all these steps in your formula notebook, and then let us see an example over here. We have a differential equation, and boundary conditions are given, and we have to find the solution. So I can write this equation as d square minus 1 into y is equal to 2 cos ht, and my f of d is d square minus 1, and r of x is 2 cos ht. First step is to find the CF. Yes, CF, okay, the solution is CF plus PI. So first step is to find the CF, which is d square minus 1 equal to 0. And then I write the auxiliary equation, m square minus 1 is equal to 0. M will be plus or minus 1. M1 will be 1 and M2 will be minus 1. So these are real and unequal. Therefore, CF will be A e power t plus B e power minus t. So next step here is to find the particular integral. We have to find r of x is equal to 2 cos ht. We don't have any type to solve this kind of question. So 2 cos ht can be written in exponential terms. So I have replaced 2 cos ht in terms of exponential term, which is e power t plus e power minus t. And now we are going to find the particular integral. So first step is write f1 by f of t e power t plus e power minus t. Remember that a is equal to 1 over here. So when you substitute p of I, particular integral, that is your f of t is d square minus 1. So when you substitute a is equal to 1, you will get your denominator to be 0. So I am going to do a differentiation of my term. So I am going to solve it by second step, which is multiply t by differentiating 2d into e power t plus e power minus t. So this first thing, like the differentiation is for our first term, e power t term. Now if you see, we have other term which is e power minus t. So for that, I am again going to differentiate my particular integral, which gives me t into 1 by 2. D will vanish, d will be 1. So it will give me t by 1 by 2 e power t, and on differentiating e power minus t, I get minus e power minus t, which is this. So my particular integral now will become t sine ht. Therefore, I can write the solution to be y is equal to a e power t plus b e power minus t plus t sine ht. So now we have to apply the boundary conditions. So on applying that, I get this two equation, and from these 1 and 2 I can find that a is equal to 0 and b is equal to 0. And then when you substitute these constant values in your y solution, you get y to be t sine ht, because the first two solutions will go to 0. So thank you. I hope you like this video, and share this video with your friends if you want to help your friends. So, like my videos, share my videos, subscribe my channel, and do not forget to hit the bell. So, see you tomorrow. Ta-da!